We can also imagine robotic parts replacing body parts of non-disabled people. Are there some limits that should not be crossed in your opinion, or is it okay to freely explore any direction for now?
Which body parts are you thinking of replacing?
Any part.
Tell me how much money you have, and then I'll tell you what's possible. My name is Majid. I will be hosting today's event. And before I do that, I'll talk a little bit about InnoHyve and who we are and what we do. So InnoHyve is a recruitment-focused events company. So we really try to give back to the community as much as we can through events like these, where the goal for us is to connect people with other people they might find interesting in the Tokyo tech community, right? So after kind of the talk, there will be a time for you to ask questions of the panel if you want, as well as to network and mix and mingle with people, right? So with that said, let me get into today's event. So we'll be talking about drones, robotics, right? And we have three awesome panel members. And if you can introduce yourselves one at a time, that would be awesome. So I'll start to my left with Wilson.
Hi, nice to meet you guys. Woman. I'm Wilson Colin. I work currently at LexxPluss, and I'm a mechanical engineer, the lead mechanical engineer in LexxPluss. And I've mostly been working on robotics. So if you ask me to design a car, I'm not your guy, but if you ask me to design a robot, I'll be more than happy to help you. And how I came to robotics is I was always interested in reverse engineering when I was a kid, like disassembling everything, of course not reassembling it. And after high school, I wanted to be an engineer, and I got an opportunity to work to study at a university with a robotics program, and that's how I ended up in robotics.
Thank you, Wilson.
Hi, everyone. Nice to meet you all. Today, my name is Charith Fernando. I'm actually representing Avatarin, a company which does telepresence robots. Our main target is actually like combining robots and AI and mass distribution of the robot fleet and so on. So our robots, maybe some of you might have seen already in the airport because that's one of our field. So we work very closely with All Nippon Airlines. That's our main mother company. So yeah, that's it. Yeah, thank you very much.
Hi, I'm Satoru from Aerosense. Who is Japanese here? Oh, okay, a few. Okay, I'm Japanese as well. But I studied philosophy at the University of St Andrews in Scotland. So that's why maybe I can speak a little bit English than Japanese, average Japanese people. And so after graduating university, I joined management consultant in Tokyo, and I did about 7 years there in total. And then after that, I started this company, Aerosense. It's a kind of joint venture between Sony and ZMP, and we have done business for 9 years already. So it's kind of very later stage startup. Drone company, ne? Drone company. Aerosense is drone company.
Cool. I think, Wilson, you said a little bit to this effect, but I wanted to ask each of you, just as a quick icebreaker, like what got you into robotics or drones, right? Any one of you could start.
Sure. I came to Japan, I think, in 2007 or 8. So at that time, I was doing robotics masters. Then soon I did my PhD. At that time, my suppose I was interested in humanoids. So that's actually when I was like doing my PhD work. Actually, ended up in teleexistence. That's actually where you were previously working. So after that, like for master deployment and stuff, I joined the Avatarin. So how I became, I think I'm just was like curious on mechanical, electrical things. I was also like making things. Didn't break that much, but Legos, like those mechanical systems and stuff was like from the early stage. That helped me to break down the systems more, understanding how things works and so on. So I think that might have been helping the way along.
I did management consulting, but kind of wanted to start my own business, but it's very hard to do it, on my own. And it just happened to be this kind of event where I met Taniguchi-san from ZMP, and at that time they have decided to start this company Aerosense with Sony. I knew that later on, but that was the day they decided. So it was a very pure coincidence. But why I interested in this kind of robotics business is that my ultimate goal is to kind of explore the space, the universe. But to do so, I think we need a lot of AI robots because we are human beings like raw materials. It's very hard to survive outside Earth. So I think we need to kind of collaborate a lot with AI robots. So that's why I'd like to kind of develop this AI robotics business for that end. Yeah.
That's cool. Yeah, kind of. There's a callback there, I think, to our previous event as well, which we did on Spaces. But yeah, Wilson, go ahead.
Sure, I had a few more words.
Sure.
So what I like about robotics personally is that I like to build things, and if you just build a platform and it cannot do anything, it's a bit boring. So if you start connecting some sensors with some motors and everything start to interact together, and then you try to put some logic, and it becomes very fun to like just make things, like understand the environment and start behaving based on the input they receive. And that's how I ended up in robotics. And why the mechanical side is because electronics, I keep burning the PCBs, and I thought that was not fun and expensive. And software, I was always struggling with the libraries to install them. Everything was not working. And then mechanical was relatively simple to me, and I was like, well, then I guess I'll be a mechanical engineer. And yeah.
Cool. So I wanted to ask each of you kind of, how do you foresee the field that you're working in, right? Whether that's in drones with you, Satoru-san, or like in general with robotics. How do you see the field kind of transforming human interactions with the world, right? So right now, I have to wash my dishes with my own two hands. Is that still going to be the case in 5-10 years from now?
Okay. So I'm a drone guy. But it's very hard to fly drones like here in Tokyo. But actually, we really contribute to kind of construction sites or more like on-site operations. It's not like office work. We help workers on-site, like for example, inspection, dam inspection, river inspection, coastal line surveillance, or that kind of things. It's very kind of, sometimes it's very cumbersome and very tiring and very risky for somebody to go there. So instead of that, we can fly our drones to cover large area. So I think so you don't see drones in your life because it's far away. It's rural areas where you don't live normally. But yeah, more and more drones will be flying, especially our drones. Yeah.
Yeah, we are actually in the I think the great time that where we see AI and robotics comes together, and I think the recent advancement in humanoid robots I think Wilson can tell better. I would say like the mechanical, most complex things, actuators, sensors are getting cheaper, more like robust and stuff. So we are seeing more and more new robotics companies, robots distributed among the field. So yes, with AI advancement and stuff, I think it's easier to build robots than before. Yes, with that, I think it's easier to help people. But washing dishes or something like that, like all manipulation task, will still need some time. But I think it's picking up with like all these LLM models, like AI assisted things very like fast. I think Japan is one of the countries that will adapt it very quickly because of the decline population and stuff. So that's one of the things that we are also like focusing our robots in the airport. The projections shows that the staff in airports will be declining rapidly. The people who can give work in the same physical space will be declining. So we are trying how this can be matched with robotics and so on. So we are more focusing on like soft things like communication, detection of these things and so on. But of course, like it has some advanced robotics as well. Yeah.
So I used to work for a company called Telexistence, and this company is making essentially not humanoids, it's more like industrial robots, where you have basically a robotic arm on a column, and the goal is to pick drinks from one side to the other. It's a very repetitive job. It's in the environment, it's about 5 degrees, so you don't want to spend time there, right? So in that regard, I think robotics can be very helpful because there is many jobs that people don't want to do that are not very comfortable to do, like working in a fridge, working in a freezer, and that's where I think robotics can be very helpful. But the main problem with robotics, it's very expensive. Like actuators, it's like thousands of dollars. Like designing a part from the mechanical side, it's like, I don't know, prototyping just a metal part is very, very expensive. You can like spend some money just for one part. So it's a big budget, and if your robot cannot do that much, then why would you spend that much money on it, right? So the thing is, with AI right now, you get the chance to do a lot more things with your robots, and even though it's expensive, you can do more things, so it becomes more interesting for you to purchase robot. And more actuators and sensors are getting cheaper, and I think we are getting to a point where robots can do more things, and they are becoming cheaper, and that's the good point to get more companies involved in robotics.
So let's talk about the AI then a little bit, right? So we kind of touched a little bit on the surface of it, but what do the recent advancements in AI like enable on the robotics side of things, right? What is now possible that wasn't before?
Sure. What's not possible, I think the biggest difference that we see, not about the technology, but the technology is being used in wide range of robots and in the real field. Because until now, of course, like people have used for demonstrations, working on the computer and stuff, but like running it daily, getting the data, making it robust, making the right decisions, this large level of like data collection and making it use is something different what we see. There's not much new, how to say, like leap, I would say. Some areas like LLM, chatbots, I think you can see, these are like some areas that is very quickly picking up, especially in Japan because of the language barriers and everything. So this can solve a lot of things for especially the foreigners, and also like the communication between Japanese communities and like foreigners and so on. Yeah.
So actually, in terms of drones, we do not use a lot of AI. It's very like an automatic process. so everything is kind of hardwired. It's not very like judging or sense kind of it doesn't involve AI kind of judgment. It's very kind of hardwired objective things. But we take lots of data and we upload the data to the cloud, and then the cloud system maybe use AI to detect something. That's how kind of we use AI at the moment. But as things kind of move forward, maybe we can utilize, for example, Jetson or NVIDIA's AI chip on board. And that can maybe detect something and avoid something that might happen in the very, very near future. Yeah.
So AI is not my field. I'm more on the mechanical side. But one big advancement I've been able to see with AI is in computer vision. Now we are able to detect a lot more things in an image at a much better frame rate. And the frame rate is everything in robotics. It's like if you need 10 seconds to detect something in your image, then it's already too late. Your robot already did some actions, and you might already be running into something. So I think the AI is reaching a level where, at least in computer vision, we can understand a lot more about the environment. And as a result, for the robot, it gives us a lot more possibility about what we can do in there. And I think it's a very interesting time on the computer science side. Like for the electronics and mechanical, I still have some, I don't see that much advances in terms of AI. Like you start having some research paper about how they can use AI to optimize mechanical engineering or electrical engineering, but it's still very much lab oriented and it's very hard to bring into the industry.
Cool. So for Satoru and anybody else who wants to answer this, right? Like, so you mentioned kind of, at least for the drones that you work with right now, you don't work that much with AI specifically, right? So are those drones autonomous, semi-autonomous? Are they driven by humans, right? Like, what does that look like? And yeah.
It's fully automatic, so kind of all you have to do is to set up flight plan. And flight plan is very easy. You just put waypoint on the Google map or something. And then you make or a flight plan can be created automatically as well. And then our drones just follow the line. So you don't have to really kind of hold something like controller. No, it's all it's kind of it's just like this.
Makes
Push
sense.
the button, then go.
And then is the main use case for taking like aerial imagery or?
Yeah, mostly photos.
Got it. Cool, cool. How about with you two? Like what kind of robotics, what kind of robots are your teams working with? Mostly autonomous or human?
We do, at the moment, what has been deployed is autonomous, not autonomous. We use like a semi-autonomous kind of thing, so it's guided, but also the human in the loop always, because that's the first step of having it. But when we talk about autonomous navigation in the land or inside a building, especially like the areas that we are working on is like airports and stuff, it's huge. With the dynamic movements, people moving here and there, it's actually a complex task as to completely give autonomous to a robot. So we are in the pilot stages of how we can achieve that in the future and so on. Yeah.
So in my current company, which is LexxPluss, we are working on AMRs, which is autonomous mobile robot. And we are mostly working in warehouses for logistics. And like this application of autonomous mobile robot has been working pretty well without AI so far. And I think there is not that much, there is a lot of improvement we can do, but at the moment it's really really complicated to integrate all the power of AI. I think one thing that is starting to appear a bit more in my industry is that the control of the robot, like for example, a robotic arm or a humanoid, you need to know exactly how to move each joint so that you can reach a specific location or you can do a specific movement. And same for your mobile robot. You need to know exactly all about the kinematics, like how will the wheel move and how will your robot move to be able to bring your robot from point A to point B. And there is recently like something we call reinforcement learning, where basically you don't tell your robot how to move, you just put it in a physics engine with all the properties of your robot, and it kind of try to figure it out by itself. So it will just do trial and error until it goes from the point A to the point B and then reach the target. And more you can see that the software engineer are requiring like high fidelity models that they can include in their physics engine so that they can just make it learn by itself to reach the target so that we don't have to make all those complicated equations, all those control loop where you have to do the tuning, which is very troublesome because as soon as you change the environment, then all your equations are not working anymore. It's like if you use a floor with very high friction, then you don't care about slippage. And so you will do all your mathematical model without slippage because it's easier. But then if you start to get some water on the floor and there's slippage happening, then your mathematical model is not working anymore because now you're starting to slip. Your odometry, like measuring where as your robot moved, is starting to like get crazy because you didn't expect that. And so reinforcement learning is a good alternative because now we can get rid of the model and just learn to adapt to your environment.
Makes sense? So in terms of the industry overall right now, right, like what do you see as being the biggest challenge to wider adoption of robots in society? And it could be a technical challenge, non-technical challenge, anything.
Technical challenges are actually with the advancement of like technological advancements actually like getting more and more cleared out. Still, I mean, we run robots actually on the airport and stuff. The adaptability is something that is very difficult for the people, especially the elder age people and so on. So having a robot in a common space and being interacted, being served is actually everyone's dreams, but actually the UI and everything becoming more understandable is actually a very big thing when it comes to make universal designs. So that's one thing. Technical wise, I would say still scaling robotics business is still a challenge because there's so many unknowns which has like, so for example, we use communication, so it has to constantly communicate with our cloud. We use LTE, 5G, Wi-Fi networks and stuff. We have good areas, bad areas, so all the when the network goes off, what needs to be done, how the user has to be treated, and these kind of things. So it's still a lot of challenges we face also every day.
I think what I could add to that is that in robotics, you can differentiate two very different applications, which is unstructured environment and structured environment. So in my current company, we're working in warehouses where everything is very well structured. So you can tell your robot, you're not going to expect any kids running around. So you can be pretty safe. You can reduce your safety distances. But for the airport, I think it's a lot more unstructured, and your robot needs a lot of awareness of the situation, of the environment, so that it can respond appropriately and not put people in danger. So I think the difference between unstructured and structured environment is everything, because structured environment is very easy to handle. We have been handling very well so far. Like if you look at the manufacturing facilities in China, they are using robotics arm. They are programmed perfectly and they do the job very well. But it's very limited because you need to program everything. And unstructured environment, you don't want to program too much because you want to be able to leave some room for the robot to like kind of understand the place, and that's maybe one of the challenges right now. And the second challenges that I see is batteries, because our current robot needs batteries to run, right? And we can run about 18 hours, but then we need to charge it. And so like the fact that you don't have unlimited like battery means that you need to do a lot of management for your batteries. You need also to be careful of your batteries because they're kind of bombs, right? If you puncture them, they explode, they take fire. So all the battery management is still, I think, a huge bottleneck in robotics because motors are using a lot of electricity, and yeah, that would be nice to get better batteries, basically.
Makes sense. Satoru, how about drones?
Yeah, it's kind of interesting. So we fly in the sky. Sky is very free, so it's easy to use drones. But I always do some sales activities. So I talk to many people, potential customers, and many people will say, "Okay, it's automatic, but who is going to fly the drones? You know, who is the pilots?" They always say that. So I think to kind of overcome that kind of psychological hurdle, I think we need to have a drone pod or drone nest, because currently somebody has to be there to set up drones, to check and change batteries. Somebody has to do that. So if drone pod or nest can do that kind of thing automatically, then it's very automatic. And then maybe many, not many people, many companies or many municipalities will adopt drones instead of human beings going there. Yeah.
Makes sense. And what about like business or kind of commercialization difficulties with drones or robotics, right? So we talked a lot about technical things. What kinds of roadblocks are there on the business side of things?
For the ground robots maintenance, proper pipelines for maintenance is one. I mean, it's not a huge challenge, but it also is a lot of effort that has to be done. A lot of still humans are involved, so we are trying to reduce the human involved in all this automation, but still we use for example what Wilson was saying, the batteries. Some robots needs to be changing the battery by humans, some can auto charge, some has to go to the dock by human assist. So these kind of things still we use some sort of like human in the process. So we are trying to reduce the human involvement, but still we are really using humans. So that's one challenge that I mean, especially like countries like Japan, while fighting for the population and so on. The second thing I would say is the cost, affordability for the general public or the audience that you are catering. So this one, actually the price compared to, I would say, 5 years ago is dropping, but these days actually with the inflation a little bit extra, but that's keeping it aside. I think the cost for a normal household to own a robot that can be used in a real usable environment, you have like robots that is sweeping the house and so on, but like if you want to do more, still you will have to pay a lot. Then what would be the actual work that you're going to get is actually there's a like a mismatch still. So that's one of the reasons that we are also targeting not individuals but corporations that can host the money first, so then it can be a shared resources for those who want based on like a subscription kind of thing.
I think I do agree. Maintenance is awful, like because so I'm the mechanical guy in my company, right? And if something breaks, it's my fault because that means we didn't design it properly. And you know, like your car, you need to do maintenance every 2 years. If we can reach that with a robot, it's awesome. Like it will solve so much of our troubles. Like right now we have, like in my current company, we still do have a lot of maintenance, and it takes a long time to get a product to a level where you don't need that much maintenance anymore. So yeah, I do agree maintenance is quite difficult. And the second one will be standardization, because like in the logistic business, everyone they have their own facility, their own like carts. Everything they use is their proprietary. They optimize it for their business. And so when we try to provide a robot, then we have to adapt to their use case. And then when we go to another client, we need to adapt to their use case. And so for a robotics company, there is so many customization that you need to do. And each customization is something that you need to take care, right? You cannot just make it happen and then just leave it on the side. You still need to do maintenance. You still need to improve the design. And once you have like, I don't know, 5 or 6 clients and they all have a custom product, then that's a lot of development for your teams, because you need to make those products like live, right? So even though on your website you have only one product, actually in reality you have 6 different products, because each client has different needs.
Okay. Yeah. It very depends on how you compare the alternatives. Yes, sometimes people say cost, but for example, we provide VTOL. It's a fixed wing drone that can vertically take off and land, and it can fly up to 50 kilometers. And then our new model will be flying up to 150 kilometers, one flight. Then we can replace helicopters and small airplanes. And if you want to buy helicopters or small airplanes, that's very expensive, right? Our VTOL is like buying a car. So it's much cheaper, and the maintenance, it's all battery driven. So you only have to pay electricity. So that's very cheap. So I think, yeah, every day I do sales activities. I think psychological hurdles is much higher, because they don't know how they can utilize these VTOLs or drones. And it's not really about individual consumers. It's more about very B2B and B2G, how we can maintain our infrastructure where we have less and less people on the ground. Yeah.
Makes sense. I think the kind of B2B, right, business-to-business applications of kind of both drones and robotics seem to make sense as an initial standpoint, right? Because bigger companies are kind of the only ones that can pay for some of these use cases. With that said, where do you think the kind of next consumer applications are going to be, right? Like, where do you think the big consumer application is going to be that comes next? So, as an example, right? I don't know, maybe some of you also have like a Roomba or a robot vacuum in your house, right? As much of those damn things are kind of, get stuck like in here, right? I set it in my house, I come back 12 hours later, it only cleaned half because it was stuck. I still prefer that over vacuuming myself because I have really bad dust allergies. I don't want to mess up my back. Even though it's the early days of that, right? It's still really nice to have that in my house. Now, coming back to the washing the dishes kind of thing, like what's the next consumer application that we'll see with, robotics and drones, in your opinion?
Yeah, in my opinion, robotics, especially like humanoids, I mean, we have seen movies and stuff like it's in your living room and stuff. I think I'm doubt that if that's what the people wants, because you have an expensive toy will do something for you, but I would say the devices around you are already smarter. Like look at the microwaves, ovens, dryers, and everything. It's just that you just need to press some buttons, and it does the job already. So these gonna come more and more smarter. and it's going to help the people in the living rooms and stuff. So what I believe is actually the home or like a room environment is already not changing. So it's very easy for a designer, engineer perspective to optimize it with a fixed device or something. I mean, we could call it as a robot, your robot vacuum cleaner, but it's just, I think, a more self-catered device than a multi-purpose one. So the multi-purpose ones are more useful in public places where it can cater multiple people's multiple needs and so on. That's what I think.
What's an example of this kind of multi-purpose device?
Multi-purpose device on a non-home environment, I think, I mean, it could be, so the airport scenario, I will pick up what we are actually doing. So in the future, like airports will be sort of like patrolled by these kind of robots in searching for the people who needs help, including the people in the airports, because airports is a very like chaos, like place that you always like you're gonna miss it. You come always in the wrong time or something, you know. So of course, like there's cases. So rather than like asking someone, like you need like more specific guidance and so on in order to. I'm pretty sure like all of you here have that moment in an airport that you got like that kind of a time. So in that case, you don't want to call someone like by a phone or something. You want like very immediate response. I mean, that's where the information boxes and so these will be actually moving around you. So whenever you want, you can actually like get help what you want. And also like talk to actually agents, use LLM to process what has been already known, these kind of things, and like predict the environment changes, these kind of thing. Yeah.
Okay. Satoru, Wilson, what do you think?
I do agree that robots are so expensive and for the consumer it's not worth it. But there is one consumer that actually benefits a lot from robotics, and that's our disabled people. There is more and more robotics prosthetists that are doing amazing things. Like in Switzerland at the EPFL, they designed an ankle that can understand where you are working, if you are climbing stairs or if you are working on the rough terrain, and adapt the way the ankle will move so that it can feel better for you. Or like, I don't know, like arms and hands, I think are amazing because disabled people don't really have that much option right now. And if we can decrease the price of those robots, it can really have a meaningful impact on their life. So as a consumer, I think they will be the one that will first benefit from it. And
I'm B2B guy, so no idea.
Yeah, I guess we're not going to be able to fly drones in Tokyo anytime soon, right? Cool. So wanted to kind of also open up the floor for audience questions. I think I managed to answer or ask most of the questions that I personally wanted to ask. But yeah, anybody interested in asking questions? Yeah, go ahead.
So we already asked about like obstacles of like spreading the robotics, and I'm surprised like none of you mentioned about regulations, like how friendly it is. I had more drone in my mind, but like would it help if you can fly in Tokyo, or is it realistic? And then if you can compare with other countries, that would be cool. I'm curious how it is in these countries. So.
That's me, drone. Okay. Yeah. So actually, this is how I see this situation. Japanese drone regulation is very well structured compared with other countries. For example, in the U.S., there are so many drone companies as well there. But FAA, Federal Aviation Authority, it seems to me that they kind of individually judge whether this drone maker or these services are okay or not. It's very case by case. Yeah, it's very English, case by case. Yeah. But in Japan, it's more like we have rules, so everyone can understand this, and everyone can so see whether this is okay or not because they are written rules. So I think in that sense, Japanese strong regulation is very clear cut, but it's not very complete, of course. Drone is a very new thing. The robot are very new things. For example, VTOL has got a type certification, meaning our VTOL itself, this is type certified. It's like an airplane. But the current regulation requires to have a kind of, how can I say, a multicopter type license as well as fixed wing license to operate VTOL. But our VTOL, it's fully automatic, so you don't actually need a manual fixed wing license because you don't fly it manually. And as a maker, we dysfunctions the manual mode to get this type certification. So this is very discrepancy happening right now. So we are currently working with the Civil Aviation Authority in Japan to fix it because it's wrong. You are wrong.
Are they cooperative? Are they cooperative or it's very hard to work?
Yeah, it's cooperative. It's is this online? Okay. But it's English, maybe don't
We can cut it.
Yeah, it's kind of funny thing. They said that they have kind of decided to incorporate this kind of manual fixed wing licensing, and there's a kind of advisory board, right? But they're not gonna invite us to the advisory board. That's funny, right? Because we are the one to make and operate our VTOLs, I think most often in Japan. But they're not gonna invite us to the advisory board. So who is making that decision? Right? They don't know VTOLs, but they decide that kind of thing. So, yeah. Right.
Next question?
Edit that part.
No problem.
I was actually also going to ask about the regulation bit. I work at a government relations consultancy firm, and the reason I come to these InnoHyve events is because I serve IT clients, but I'm not in the IT field. I don't have a lot of knowledge, so it's really interesting to learn about all of your fields. So that was really interesting to hear. I wonder about the robotics field as well. As a few of you have mentioned, the government is really concerned about the declining population in Japan, and in many policy documents, they note how important drones and robotics will become in the future. And so I wondered on kind of the flip side, if you're finding, if any of you, first of all, are collaborating with the government. Also, Satoru, I believe you mentioned municipalities. I'm sure there's a lot of digital city, smart city potential collaborations there. So I wonder if you're finding quite a lot of support and for the work that you're doing from the government. And then this is also a question for Satoru, if I might add just one more. I just attended the Space Tide conference held by the Space Tide Foundation on Tuesday and was learning about how Sony is actually doing a lot of work in space, like they have a satellite in space for space entertainment. So I think maybe you can't talk about some of the work you're doing, but if you have any specifics on the work you're doing collaborating with Sony in space with drones, I'd be super interested to hear. Thank you.
Sorry, Mary. If we can rewind a little bit. So there's two questions, right? Mm-hmm. What's the first one?
So the first one is if you're finding any really positive kind of momentum from the government, or if your companies are working at all with the government, getting support from them even.
Okay, let's focus on that one first, and then we'll come to the second one. Okay, so is your company getting support from the government?
The government and also from the industry leads, actually we are getting support. it's a question a little bit. I mean, is the support that we want, but I think it's changing, especially like running a robot in the airport is like everyone is like really concerned the typical way. Okay, if it hits by someone, like what's going to do, who is going to responsible, who is going to pay the thing and so on. But the things, the mindset and everything is changing. And also the regulations are also coming, so this is actually helping the other companies to actually like move forward and so on. Yeah.
So in terms of drones or robotics, they are very supportive. Municipalities as well as central governments, and they provide lots of monetary funding as well. But there's a but. It's kind of project based, but as a company, we would like to sell our hardwares. So that's kind of another story. So robotics and drones are new tools, so it's not easy for them to actually purchase these kind of things, and they are, in general conservative. So yes, they are supportive in that sense, but in terms of really buying things, it takes a lot of time to convince them. Yeah.
And then Mary, you had a second question, right?
Yeah. So it was just if you have any information, Satoru, about exactly kind of like the space collaborations you're doing with Sony. I'm kind of a space nerd. I would love to hear more about what exactly you're up to.
And then if anyone else has a question, raise your hand, please.
Yeah. So more than 40% is owned by Sony, our company, but actually we are very independent in terms of business activities because as you know, Sony is more like for consumer business, but our business is more B2B and B2G. So there is not much kind of interactions in that sense. Yeah, but we use their imaging sensors because we do lots of camera imaging. So that's how we collaborate. And but personally, I'm also interested in space. Yeah.
Yeah, go ahead. We had a question in the back.
Yep. So it was mentioned that robotic parts could benefit disabled people. We can also imagine robotic parts replacing body parts of non-disabled people. Are there some limits that should not be crossed in your opinion, or is it okay to freely explore any direction for now?
Which body parts are you thinking of replacing?
Any part.
It's just my personal opinion, but I mean, it's your body, right? You can do whatever you want with your body. So if you want to replace your legs to be able to run faster, because nowadays like the prosthetic legs are just better than real legs, right? They are lighter, so if you want to run, it's kind of easier. And if that's what you want, I don't think we should have anything to say about it. It's your body, so. Yeah, that's all I could share.
Yeah, I just thought that that's the power of consumer business because you can decide. But if you talking about B2B or B2G, many people join that conversations. Many people say something. So it's very hard to make an innovation or innovative things. But yeah, consumers, well, if you are okay, it's okay. That's where innovation happens. Yeah, that's my comment.
I would say the more and more processes we will see, there will be standardization and regulations because to protect the people, I would say. So, I mean, it's in Japan, in my understanding, we don't see that much yet, like electronic powered processes. So, of course, like manual is, of course, there. So I think there will be a time that we will have some limitations and stuff. I mean, I've seen probably the Elon Musk brain chip and stuff. So there will be obviously limitations or standardizations will be adding by the government or by other bodies. Yeah.
I was gonna say, tell me how much money you have, and then I'll tell you what's possible.
Hi. So from a sort of business perspective, how do you convince clients, potential customers, that they should use robotic solutions, and also how would you differentiate yourself from any competitors?
So first question is, how do you convince customers, right?
I'm a business guy, so it's your heart, passion. It's very because if people make a decision, it's very kind of emotional actually. So and you have to hit the iron where it's hot. Yeah, does that make sense in English as well? I just translated that into English. Yeah, good. So it's very important, and it's also important to show how they can use our products. It's not so yeah. Demonstration is very important.
Which is, how do you differentiate?
How do actually? So our Vuito is type certified. This is the first Vuito ever type certified. So in that sense, our product is very matured. In that way, I think we differentiate. And everybody I think knows DJI. DJI focuses on multicopter type drones, but our main products right now is Vuito that DJI does not create. So.
I think like when you have a robotics company, you're trying to make one product that you can use for as many clients as you can so that you can make money, right? But the thing is if you don't customize enough, then it's not gonna solve exactly their problem. And if you can find a design that solves exactly what they want, then you will be able to differentiate yourself from other companies because you will be trying to solve one big pain point that they have. So that will be a good way for you to differentiate yourself. But if you customize too much, then you are kind of locking yourself with that one client. So finding the proper balance between customization and standardization is the tricky part in robotics.
Anybody else have any questions? No? Okay. So then let's maybe wrap it up a little bit early. I don't know if we're good on time, but... Yeah, sure. Who are you asking?
So I'm also very interested in AI, and generative AI is very key things forward, and I'm kind of looking forward how generative AI can kind of advance our robotics, especially humanoid robotics or animal robotics in that sense. So if somebody has any comments or opinions, please say something.
Generative AI actually has been used if anyone has used Isaac Jim by NVIDIA. Actually Wilson was previously saying about the reinforcement training. So it used to have previously, we allow the virtual model or the actual robot to explore all the possibilities, but it's getting more knowledgeable right now that with generative AI, they can predict the poses and stuff in virtual environment. So actually the name is funny. It's called Isaac Gym. So you can send your robot to the gym, so you can do all the workouts and stuff. I mean, it's just joking, but it will actually give all the possibilities of what that robot could learn in an environment and so on. So these are generated sometimes, like some research has been done in real time as well. So the people doesn't have to develop a lot of things. And warehouse automation already uses by navigation from 3D LiDARs to generate object models, and these kind of things are getting more and more like autonomous, generative, and so on. Yeah.
Can I ask a follow-up question to that?
Sure.
How much? How much do you think the robotics industry is like relying on AI to advance as well? And what if the hype train, because I think there's a lot of underlying, it's going to be hype all the time. What if it flattens out? How would that influence the robotics industry in a way?
The AI is actually used in multiple stages of product development, actually. So from design to train, then also like when like using it in the customer and so on. So most of the AI that you see is actually on the design stages, like predictions and all these things. Then also in the consumer side, like application wise, that you can see value-added services in a form. So predictions, I'm not really sure if any robot in the field right now using generative in the sense predicting trajectories and stuff. But I think maybe you might have seen the Tesla bot, the work that has been doing. Basically, I mean, it can predict in on real time based on the environment changes and so on. So with the big computers, GPUs and stuff, like it can actually predict things in real time already. But using it in a real situation, that's I haven't, I think, seen that. I mean, you can make a video with lots of failures and some success and so on, but in a day-to-day situation, I would say it's still very early stage to try something in the field.
Yeah, to add to that, I think there is a lot of hype for like generative AI for consumers. But for robotics company, we are still very, very far from integrating the AI into our system. And one thing is, for example, for reinforcement learning, you essentially ask your robot to learn by itself, right? And the problem with that is if it encounters a situation it was not trained for, we don't know how it's going to react, right? Well, if you use more like legacy control theory, where you use the mathematical equation to plan everything, then you can make your model such as if there is some disturbances, you know how your robot is going to react. And if you know how your robot is going to react, you can ensure that it will remain safe. But with the AI, if you don't know how your robot is going to react to a new situation, then you could endanger people. You could break your robot, and that's not good for a company. So there is a lot of... It's hard to bring AI into robotics because we want to know what's happened. We don't want to let the robot like make decisions we don't know about.
Yeah, before I give the mic to you, I actually did want to talk a little bit about the Gen AI question, right? So I would put a fat disclaimer on this that I don't know if it's even labeled as generative AI in this particular use case, but what I have seen in autonomous driving, like both at Toyota as well as at Google Waymo, right, is a lot to do with simulation. So a lot of car companies that are working on autonomous driving algorithms have issues with kind of generating enough type of scenarios to make sure that the car is actually safe or is actually running through those scenarios in the real world, right? So there are some edge cases that they encounter in the real world, like you can imagine like a fire truck, for example. you properly recognize a fire truck, or you recognize a situation in which you're supposed to yield to an emergency vehicle, that's pretty difficult to encounter in the real world unless you're causing your cars to like loop around a fire station like all day, right? So there's 3 cases where I see generative AI has been applied for this. So one is to generate the long tail of edge cases that you need to test somehow, but are difficult to encounter in the real world. So in simulation, you'll generate scenarios that are like, okay, put a fire truck in the scene, or put an ambulance in the scene, you know, change the weather, blah, 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 whatever, right? Then the second case would be to generate synthetic data. So there's a company called Parallel Domain. They have a really cool name, by the way. That name is really awesome. What they do is they generate synthetic data for the purpose of machine learning. So you can imagine, like, you have a photorealistic image, but for like a lot of these car companies, they have a bunch of sensors on their vehicles, right? So LiDAR sensors, they have cameras, they have radar. For cameras specifically, so in Teslas, for example, they only have cameras. Like Elon Musk is very adamant that they only use front-facing cameras. So in their case, if you wanted to generate synthetic data, what you'd need to know is the parameters of that camera, right? Like what resolution that camera takes images in, and then sort of create fake data that looks like it came from that same camera. And that would be the ideal case for generating fake scenarios, basically, that never occurred. So you could insert like a pedestrian, for example, into the scene in a crosswalk, and then change the pedestrian from being like, you know, I don't know, 2 meter tall, really tall guy to being, you know, a short woman or a child, something like that, which you cannot easily encounter in the real world, right? And even if you did, you'd have to run that scenario many, many times on like a closed course or something like that. Whereas you could say, okay, use that intersection. It's a real intersection. Actually generate the data there, right? And then the third case I saw, which I think Waymo wrote a paper on this, is they took crash data from a whole bunch of different common crash scenarios in which human drivers actually would not be able to react in time, or they were the causes of like many fatal accidents in, I think, the US. And so they wrote a paper on this where basically they took this national highway safety data, and what they did is they replaced one or both of the human drivers in the simulation. So they recreated the actual crash in their simulator. So if you just run it as if it happened, the cars crash, the people die, whatever. What they did instead is they then replaced one or both of the agents driving the car with a Waymo agent, and saw, does that actually make any difference in the outcome of that scenario? And then they ran those scenarios over and over again until they found situations in which they could actually prevent those same crashes compared to a human. So in that sense, they found that that type of training is much, much more effective than just throwing much more data at the problem, right? Because they're focusing on a very, very specific issue that they know has occurred and caused a fatal accident. But now they can actually show that if it were the Waymo driver in that hypothetical situation, nobody dies. So those are the kind of the 3 things that I noticed with Gen AI in robotics. I guess it's robotics. I don't know. Autonomous driving.
Can I comment on that? So yeah, now we are getting into very interesting parts. So I think simulation is very important in this advancement. Like if the model can simulate this kind of physical environment, they, as you said, they can learn from the simulation. They don't actually need physical actual data because they can create, like generative AI, a lot of situations, simulations, counterfactuals. I think then this is just my imagination, but then that kind of model can develop the world model, right? Like we have this physical environment, we have a model. Then after that, I think they can, if they have their own body, like senses and actuators and so on, if they can develop self model of themselves, then I think that robot can be very artificial general intelligence. Yeah. So we are, I think we are getting very close because we are now becoming utilizing simulations. So I'm very looking forward to that kind of advancement. And I think human beings also are very kind of automatic robots. Our brains always simulate, and I study philosophy, and as so if you perceive something, it's not direct perception, right? Everything is interpreted by brain, so you don't actually see or touch anything. It's all by your simulations. So the same thing to the machine. Yeah, it's always perception. It's called perception by inference. You always infer something, then you perceive something. The same thing to the machine. So
So if you have like a web-based business, like a social network, then you would try and track things like content engagement, page views, etc. Like you have metrics and you try and improve on it. So from a robotics business, like how do you track instrument things, trying to improve upon processes?
You mean how do you keep the loop of the feedback from the robot? I would say.
Um, so I guess like so one is like how do you track instrument things to get data from the robots, but not just directly for the perception or control, but actually from a sort of solving the task perspective. How do you actually track, are the robots solving this? Are they solving it quickly enough, efficiently enough, safely enough? And how do you go about trying to improve these things over time?
So we use, especially in this area, one I can share is we have like a very, very means like more than 500 fleet. So the data is being feeding to the network. We use AI dashboards to do the anomaly detection. So if the battery or something is going wrong, or if it is throwing an exception, because you cannot actually, humans cannot actually look all those logs and everything. So for logs analysis, like statistics, data, if someone changes some wrong values and so on, so these gets into curated. So that's something that's we are using for like moderation and so on. And due to that, actually we can plot the, for example, like what's the battery depletion, like if under such conditions of the customer, like how it is performing. Then the network status, as we fully monitor the QoS, information quality of service for the network, what times it drops, why it drops, what's the signal quality, then what about the other robots around it, did it also affect, if it's about this robot only. So those kind of information we use for like prediction based analysis. Yeah.
I had maybe another question. I wanted to know how AI influences the cost of robotics in terms of did, for example, some products or robots get more expensive because you used AI, and how do these costs normally calculate, or like what are they influenced from?
You mean when using the AI and the added cost because of that?
Yes, is your product getting more expensive because you use some certain AIs, or that you use or want to use simulations or that kind of stuff?
Oh, by the way, there'll just be one more question after this if there are anybody. Sorry.
Simulations actually we don't, because that's for the development stage. There's a non-recurring cost, that's how we mark. But for the real use case in real life, the most of the AI cost lies between licensing and the compute cost. So it really depends on where you are hosting, what's your computation quality, and so on. So of course, it is being added to the customer as packages and so on. But I would say licensing on our side, like we mostly do in house, so the licensing has been minimized. Computing cost is if you use like especially like LLMs and stuff, you will know it's a huge amount of cost. So we have to share, distribute, and so on. Yeah. So effective management of your cloud network when it's not being used, offloading these kind of techniques we use how to reduce the compute cost and so on. Yeah.
Could I ask, maybe if nobody else had a question to that, do you think that is a big hurdle, like the computation costs of AI to bring to the consumer? Because if there's so many consumers, there would be so many computation, and then like who's going to pay for that, right? Maybe each of you could answer that.
If I could just add
Oh, yeah.
something to your previous question, like robots are so expensive that you cannot really charge your customer more for AI. They kind of expect it by default, and the only thing you can do is like try to justify the cost of your robot with AI, but you cannot really inflate it because it's already crazy expensive. So like for robotics, I mean for cars, for example, they are cheap because we mass manufacture those cars. For robotics, mass manufacturing a robot is a huge step for a company and it's extremely hard to reach. So the cost that we are giving to our customer is kind of not yet the mass production cost. It's more like a mass produced prototype, and it's already so expensive that you just try to justify the cost with AI.
Sorry, can you just repeat that?
I wanted to know if the computation cost is
the All right.
biggest hurdle for consumers, like bringing AI to consumers.
It really depends on what computation that you requires. Like edge models actually can save money in some cases. It really depends on, but LLMs, Gen AI, these kind of things is actually not. I mean, again, it depends on the situation or the application. Multi-model, these kind of things, we really need to offload it to like a offshore, or like some cloud instance or something. So it's I would say from us, our perspective, we haven't reached a point that like you like 10,000 people need these like quarries at the same time or something, so at a large scale level. So it's still, I would say, affordable, but of course, like you have to sell it as a product so that you can get back the money that you're actually spending. So that's actually the point, not just using the technology, but also like giving some service or like a feature that people want to pay for that. Yeah.
Last question there. Do you want?
Oh, yeah, please go for it.
Sure. I mean,
It's not a serious question. So.
okay. Oh, it's not that educational question either, but it might be fun ending question maybe. But I'm coming from AI, so I'm kind of new to robotics. But you mentioned that you don't know about cars, but you know about robotics. So what's the definition of robotics in the industry? So what defines robotics, and then what defines something else?
I think the way I will characterize a robot is you have the sensors, you have your motors, and you process the data from the sensor to make an action that is adapted to your environment. You know, like your washing machine or your car, they have sensors and they react to the environment, but there is no processing to it. How to say, it's like, you know, your anti-brake system will like bring back a measurement and adapt the way you brake. And there is kind of a certain automation in that, but it's more kind of on the low level. You know, in robotics, you usually have the low level, which is your microcontroller, and then you have the high level, which is your microcomputers. In my opinion, if you're staying to the microcontroller, then it's not really robotics, because your action do not really adapt to the environment. But if you use your microcomputer to process the data, such as images, and then make some assumption and react to those assumptions, then you kind of start to move more toward the robotic side. So the Tesla car will be a robot to me, but your regular car will not be a robot to me.
Yeah, the definition of the robot is like sensors, process, and output as actuators. So in the previous days in the cars, we didn't have sensors, so that's why it was a car. And recent days, like any car, like has so many sensors, like your fuel injection, battery management system, your communication, everything is like it's a sensing and processing unit. So I think recent cars are just robots, I would say.
Cool. Hopefully that answered your question. Okay, I think we're at the end of time. So what I'd like to do is really quickly wrap up with each of you, right? So if you can really quickly summarize, where you work, if there's anything you want to share about what you do or where you work, or if you want to share, plug your personal, I don't know, LinkedIn or something like that, how people can reach you, right? Let's start with Wilson.
Okay, so I work at LexxPluss, which is a startup in Kawasaki. And we are working on autonomous AMR, autonomous mobile robot, in the warehouses to bring payloads from a point A to a point B. And we have, I wouldn't say we have a lot of AI. We have, to some extent, we have some AI to understand the environment and adapt to the environment. And if you want to reach me, I can give you a business card later if you're interested.
Yeah, I'm Charith Fernando. I work at Avatarin. Actually, it's very close. Today I came by walk. It's just in Mitsukoshima. So it's a really nice location. For reaching out, I think, yeah, I would say you could definitely, I think, search on LinkedIn. Please add, feel free to add. And also, yeah, if needed, we can exchange the business cards after this. Yeah.
Okay, I'm Satoru from Aerosense. We are drone maker. Actually, one of the engineers said this comment when we got the first type certifications. He said that we made a history. So if you want to have that kind of exciting work, please come to me and please find me at LinkedIn. Thank you.
Awesome. Thank you so much to all three of you, and thank you everyone for coming tonight. Hope everyone had a good time and you enjoyed the event. Thanks also to Brian and the Spaces venue for having us. And if you are on LinkedIn, you can follow InnoHyve on LinkedIn. If you're on Instagram, you can also follow us on Instagram. But without further ado, if you would like to get drinks, there's more food in the back as well. We'll be around for a little bit more networking, so you can also talk to the speakers or other people you haven't met. But thank you so much for coming today.